Hello everyone, welcome back to your own academy, that is Rathore Science Academy. Today we are going to discuss the chapter Electricity in the continuation of our previous video. If you didn't watch that video, please watch it. I will share the link in description box. So this topic is on your demand. If you have any other topic in your demand, you can comment it in comment box also. Without making delay, today we will discuss. Okay. So today's topics are Ohm's law, which is very important law, resistance and resistivity of a conductor. Let us start. Ohm's law. What is Ohm's law? See, Ohm's law says, according to Ohm's law, it says that V is directly proportional to I. V is what? Potential difference. Potential difference is directly proportional to the current, right? So that means what? It says that in a current carrying conductor, or you can say in a conductor, current is directly proportional to the potential difference. Current is directly proportional to the potential difference when all physical condition like temperature, resistance, pressure remains constant. When all physical condition remains constant, then what happens? In a conductor, current is directly proportional to the potential difference across the end. So when we remove this proportionality sign, what we get? Well, we get R I. V is equals to Ri. When we remove the proportionality, we will get a constant, that is resistance. It is a proportionality constant. Okay. Now see, from here we can also derive a formula, that is this formula you have to remember, important formula, and another formula you will get from here, R is equals to V upon I, where R is resistance, V is potential difference, and I is current. Now see, what is the unit of potential difference? Yes, the unit of potential difference is volt, right? And unit of current is ampere. So unit of resistance is volt upon ampere, or you can say volt upon ampere is what? Ohm. So unit of resistance is ohm. What we have discussed about Ohm's law. In that law, it's been said that current is directly proportional to potential difference when all physical quantity like temperature, pressure, resistance remain constant. And another we have discussed, when we remove this proportionality sign, we will get a constant, that is R. R is resistance, so it will become V is equals to Ri. You have to remember this formula. And another formula, this is when you have to find out resistance, R is equals to V upon I. This I will go down. Okay. Unit of potential difference is what? Unit of current is ampere. So volt upon ampere is ohm. Okay. So unit of resistance is ohm. Now see, when we draw a graph between potential difference and current, and we draw a graph between potential difference and current, then always we will find a straight line. Yes, a straight line. You have to draw it straight. Okay. A straight line graph we will find. Next thing, what you have to remember, sometime it has been asked the definition of 1 ohm. So what will be 1 ohm? 1 ohm, or definition of 1 ohm, you can remember like this. Everything will be 1. So 1 ohm is equal to the 1 ohm is the resistance which is equal when the current flowing in a circuit is 1 ampere and the potential difference across the end is 1 watt. 1 ohm is the resistance of a conductor when in a conductor current flowing is 1 ampere and the potential difference across its end is 1 volt. It is the definition of 1 ohm. Okay. Now see, even in our previous video we have discussed about resistance. So what is resistance actually is? That time I have discussed that it is something which opposes the current, right? And I said that we will discuss it later. Now we will discuss what resistance actually is. So without making delay, and remember Ohm's law is very important law. So remember that law. Resistance. What is resistance? So to understand the resistance, let us see a conductor. The same way which we have discussed later in our previous video. Now see, this is a conductor, right? Inside a conductor, you can see the atoms and electron. We have discussed that atoms and these free electrons, these are responsible for the current, right? So many atoms and free electrons are there inside a conductor, right? Now these are the atoms and these are free electrons. So we know that electricity generates just because of movement of this free electron, and when this conductor is totally free, that means not attached with any circuit, that time this electron will do random motion, right? And when the electricity is provided to them, then a continuous motion will arise. So what happened in this case when we talk about resistance? So some electron will definitely collide with atom, right? When it is attached to a circuit, then this free electron, among these free electrons, some of the electron will definitely collide with atom, right? And due to this collision, what happened? Due to this collision, the movement of electron will stop, right? So the definition will be the opposition of electron. The opposition of electron arises due to opposition of electron arises due to collision between atoms and electron is called resistance. And we know that whenever they will collide, whenever the electron and atom will collide, right, the resistance will produce, and due to this resistance the amount of electricity will decrease, right? So we have discussed previously also that whenever resistance will increase, the current will decrease, right? Obviously, if the flow of electron will decrease, then current will decrease, right? So it is the opposition of electron due to collision between electron and atom inside a conductor is known as resistance of conductor. Now see, what are the factors on which resistance of conductor depends? So let us discuss about the factor on which resistance of conductor depends. Factors on which resistance of conductor depend. So what are that factors? First, length of conductor, length of conductor. Now see, resistance of a conductor is directly proportional to the length of conductor. Resistance of a conductor is directly proportional to the length of conductor. That means what? Whenever the length of wire is increased, length of conductor is increased, right? Whenever the length of wire or conductor is increased, the resistance of a conductor will also increase. And whenever the length of wire decrease, the resistance will also decrease. So it is directly proportional to the length of conductor. Now, simply, if the wire is long, right? So, what happens? If the wire is long, the electron will collide with atom more, right? And due to this, the resistance will also increase, right? Length of wire increase, then resistance will also increase. Now, the second factor on which the resistance of a conductor depends, that is what? Area of cross section. Yes, resistance of conductor is also depend the area of cross section. And remember, these factors are important on which the resistance of conductor depend. Okay, so area of cross section. Resistance of a conductor is inversely proportional to area of cross section of a wire or conductor. That means what? That means if suppose I have two wires, right? This one and this one, right? I have two wires, two conductors. Now see, whose area of cross section is more? This one, the wire which is very thick, right? So area of cross section is more, than means what? Atoms are there, electrons are there, and see, if thickness of wire increase, then more electron will move, right? Right? So due to increase of area of cross section, what happened? There is a less chance to decrease the resistance. That means to collide with atom. So whenever the area of cross section increase, the resistance of conductor will decrease. Now see, in this wire, thickness is less. That means area of cross section is less. Less area of cross section less, that means the same way more electron will collide with atom, right, in this manner, and that's why the resistance will increase. If the more electron collide with atom, then resistance will increase. So resistance of wire is inversely proportional to area of cross section, right? So this will be our second equation, right? If resistance increase, area of cross section decrease. That means if area of cross section decrease, resistance will increase, and if it is increased, then it will decrease. Inversely proportional, right? Now whenever we combine these two equations, equation 1 and equation 2, what happens? By combining those two equations, we will get that, we'll able to know that R is directly proportional to L, right? and inversely proportional to area of cross section. We can write this like in this manner: R is inversely proportional to L by A, right? By combining equation 1 and 2, what we'll find, R is inversely proportional to area of cross section and directly proportional to length. So L by A, right? And if we remove this sign of proportionality, if we will remove the sign of proportionality, what we will get? We will get R equals to, when we remove the sign of proportionality, we will get a constant. You remember that whenever proportionality sign is removed, there is a constant will come. Okay, so in this case, which constant will come? In this case, the constant will be resistivity. So R, rho is the constant, rho L by A, and you have to remember it, you have to learn it. Okay, R is equals to rho L by A. Rho is a constant. Rho is a constant which is known as resistivity or specific resistance. Yes, specific resistance. Okay, now we'll discuss resistivity further. R is equals to rho L by A. Now see, we understand that two factor on which resistance of a conductor depend. One is length of wire, in which resistance is directly proportional to length of wire. Second, we have discussed that resistance is inversely proportional to area of cross section, right? And when we have removed the proportionality sign, we get the constant, that is proportionality constant, which is rho. Now next factor which affect the resistance of a conductor is what? Yes. The next factor on which resistance of conductor depend is temperature. Temperature. How temperature affect the resistance of a conductor? See, in case of pure metals, right? In case of pure metals, when the temperature is increased, the resistance of conductor will also increase. So we can say like this: in case of pure metal, what happened? While increasing the temperature, resistance of conductor is also increased, right? And while decreasing the temperature, resistance of conductor decreases. In case of pure metal, on increasing the temperature, resistance of conductor is increased. On decreasing the temperature, resistance of conductor is decreased. Now, second thing, in case of semiconductor, what happened? In case of semiconductor, on increasing the temperature, resistance of a conductor decreases. On increasing the temperature, resistance of conductor decreases. Okay. Now see, that means what? In case semiconductor like silicon, germanium, by increasing the temperature, whenever we increase the temperature, or semiconductor like silicon and germanium, the resistance of conductor decrease. Okay. Now see, In case of alloys, you have to learn all this, okay? In case of alloys, what happened? Some alloys like nichrome, constantan, what happened? In this case, the resistance of conductor remain unaffected. Yes. Nichrome, constantan, magnesium. In case of that, the resistance of conductor remains unaffected. And in case of what? Mercury, superconductor. Mercury is a superconductor. So in case of superconductor like mercury, what happened? In case of mercury, the resistance of conductor becomes zero at what temperature? (4.2 Kelvin). At approx 4.2, 4.5 Kelvin, resistance of conductor becomes zero. Okay. This is all about temperature. And the fourth factor which affect the resistance of conductor is what? The fourth factor is, yes, material of conductor. Resistance of conductor is also depend upon the material of conductor. So fourth factor is material of conductor. That means what? Suppose I have four conductors, four wires, right? One is of silver, another is of copper, gold, aluminium, right? So you all know that if we will arrange them on the basis of their conductivity, that means current carrying capacity, you will find that silver having good conductivity, then copper, then gold, and then aluminum. But in case of resistance, they are good conductor of electricity, and if I is good, then what? R will be less, that means just opposite of it, right? So their conductivity is like this, increasing order. So it is just opposite to their resistance. That means resistance of silver is less than resistance of copper, then resistance of gold, then the resistance of aluminium. Right? That means what? So, high resistance is of what? Aluminium, right? Aluminium having high resistance and silver having very low resistance. Understood? If we will take four conductor like silver, copper, gold and aluminium, so what will be the effect of material on resistance? If their conductivity, current carrying capacity is high, that means silver is good conductor of electricity, very good conductor. So it will be the very high current carrying capacity, and aluminium having very low current carrying capacity. And just opposite of it, if current carrying capacity is high, so then resistance will be low. So silver having very low resistance and aluminium having maximum resistance. Okay. Now till now we have discussed about Ohm's law, we have discussed about what is resistance, and we also discussed the factors, that are 4 factors which affect the resistance of a conductor. That means what? The 4 factors are, yes, first we have discussed length of conductor, then we have discussed about area of cross section, that means resistance of conductor is inversely proportional to area of cross section. Then we have discussed about the temperature, what effect of temperature, whether it increase or decrease on the resistance. Then we have discussed about material of conductor, and we have seen that 4 conductor, different conductor, what happened to the their resistance when we change the material. The resistance of silver, we see that it is very low, and the resistance of aluminium is maximum. Now the last topic on this video, not this chapter, is resistivity. And remember guys, from the practice question has been asked, and sometime, yes, I will ask one question to you. Before me moving to resistivity, I have these 3 wires, right? 1, 2, and the third one 3, right? These 3 conductors, okay? Assume I have these 3 conductor having resistance R1, R2, R3. Now arrange them on the basis of their resistance, or I will ask, arrange them on the basis of their resistance, that whose resistance will be high and whose resistance will be low. Guess what we have discussed, how we will solve? Yes, we have seen that the conductor whose area of cross section is I, the conductor whose area of cross section among these 3 is high, which one? R3. So its resistance will be very low, right? And here it is just very less, right? The area of cross section, this one is less among these 2, right? So R2 having very high resistance, right? Because its area of cross section is what? Very low. Afterward, you can see the area of cross section is R1 is little bit high than that. So R1 and R3 having high area of cross section, so it will be last. We know that R is inversely proportional to 1 by A. So with the help of this, you can solve it out. Whose area of cross section will be very high, the resistance will be very low. Okay. Now discuss about resistivity. What is resistivity? See, resistivity. Suppose I have a conductor, this one conductor, right? Whose area of cross section, if I talk about area of cross section, so area of cross section, this means this area of cross section is 1 meter square, and the length of wire is 1 meter. Then resistance of this conductor will be what? We'll solve it out. Okay. We know about resistance, that we have discussed R is inversely proportional to L by A. In the factors we have discussed that, right? R is directly proportional to length of wire, and R is inversely proportional to area of cross section. When we remove the sign of this proportionality, we get a constant. What kind of constant? Yes, we have discussed rho. The P is rho. Rho L by A. I'll be removing the proportionality signs. We get a constant, that is rho, and we have discussed that rho is what? Resistivity, or another name of resistivity is what? Is specific resistance. Specific resistance. Now see, R is equal to rho L by A. L is what? L we have taken 1 meter. So here you can get one thing more, that if you will take rho here, right? If I will take rho here, so it will become R into A by L, right? In this formula, with this help of this formula, you can find out the resistivity of conductor too, and from this formula we can get the SI unit of resistivity also. The unit of resistance we have discussed. What is the unit of resistance? Ohm, right? And the unit of area of cross section, that is, we have taken 1 meter square, so it will be 1 meter square. Length in meter, cross it out. So unit of resistivity is what? Ohm meter. Ohm meter is the SI unit. Ohm meter is a SI unit of resistivity or specific resistance. So how you will write the definition? You will write the definition that resistivity of conductor is equal to the resistance when length of wire is 1 meter and area of cross section is taken as 1 meter square. The SI unit of resistivity is ohm meter, right? And it is also known as specific resistance too. And it is a scalar quantity. Okay. So in this video we have completed 3 or 4 topics. They are very important. Keep watching, stay tuned, and if you didn't saw the previous video related to the basic of this chapter, kindly watch that video. I will share the link in the description box, and if you want more videos and related to your topic, whatever you are interested in, share in comment box. Okay, keep watching, stay tuned.